Hi guys. Today we're doing pages 27 to 29. Okay. So this is the do now. So you want to start this on your own and then restart this video and double check it. Okay. So pretend like that you have to figure this out all by yourself. Okay. And then turn me back on and check it. Okay. All right. Welcome back. All right, so Brian correctly used the method. So he correctly used it. So that means that whatever number we're going to add is the correct one. So the idea is that you want to make this into a perfect square trinomial. So to do that, we take half of 7 and then we square it. So that would give us 49 for the numerator and 4 for the denominator, which is choice 2. It's a fraction, and we all survived. If this is solved by completing the square, an intermediate step would be, well, one of the first things I would do is move the linear term to be near the quadratic term, and I would move the constant term away. Okay, so now again, I want this to be a perfect square trinomial. So I'm going to take half of -6, and then I'm going to square that, and that's going to be 9. So that would give me a 7 on that side. Okay, and it's definitely going to be the x minus 3 because that's a -6. All right. Oh, this is a little bit harder. Okay. The senior class at Bay High School buys jerseys to wear at football games. The cost of the jerseys can be modeled by the equation C, where C is the amount and cost. Okay. So $430 is what they have to spend. So I'm going to substitute that in where the C is. And then I have 0.1 x squared plus 2.4x plus 25. I'm going to set this equal to 0. So that's going to give me decimal point 1 x squared plus 2.4x minus 405. Because to move the 430, I would do the opposite of adding, which is subtracting. Now, I am totally not a fan of these numbers, so I'm going to do the quadratic formula. This would be my advice to you. If the numbers are not like integers or whole numbers or something you would consider friendly numbers, then go quadratic formula because A, it always works, and B, boom, 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 calculator. Okay, so x is equal to -b plus or minus square root b squared minus 4ac all over 2a. Okay, so now what I do when I have the quadratic formula is I always take my discriminant part and I enter my discriminant into my graphing calculator just so I can get a feel for what kind of number I'm dealing with. All right, so let's clear this out because I certainly don't need a table of values. And I don't put in the radical sign. I just put in the values that are underneath the radical sign. So that's 2.4, and then that's squared. Subtract, and you got to be careful. That cannot be a negative. It has to be subtraction. 0.1. And then another parentheses, and that has to be a negative sign. 405. Whoops, I didn't mean to hit on. I hope that didn't do anything. Okay, 405. Slightly poor calculator skills. Okay, 167.76. Totally not a perfect square. Okay, so that is underneath my radical. Okay, but it's not going to give me a non-real answer. So I can still get an answer. There's probably going to be some rounding involved. All right, so now I'm going to enter this whole thing, alpha y equals, because I want to do a fraction, and it's negative 2.4. Let me make sure, yeah, that's a negative 2.4. And I'm going to do plus first because I know that will give me a positive answer. And remember when we talked about like domain restrictions, like certain things you can't do? Well, you certainly can't buy a negative amount of football jerseys. That just doesn't make sense. All right. Oh, go to. So I typed something wrong. Always choose go to. Oh, look at that. That should be a negative sign. I had a feeling I typed that wrong. All right, so enter. Okay, 52.76. So now we need to think about this. Can you go to the store and be like, listen, dude, I can only pay for 52 and a little bit of a jersey. Will you do me a solid and give me 53? Yeah, you can try that, but it's probably not going to work. So in this case, we're going to go down to 52. Now, this is not rounding. This is number sense or even common sense, okay? So we're going to go down to 52, and we're going to say they can buy 52 jerseys. I'm not going to bother to even calculate the negative answer because, once again, think about it, right? You can't buy a negative amount of jerseys. Okay, so I can only afford to buy 52 jerseys. So hopefully that's enough for everybody that wants one. I don't know how big this Bay High School is. All right. Okay, number 4. The height of a cannonball can be modeled by the function. So, all right, here's my really bad drawing. Okay, so like a cannonball comes out and it comes down. So you can see that it's parabolic, which means it forms a parabola. All right. So obviously this probably should have been pointing up a little more, but hey, we like me anyway, even though I'm a really bad artist, right? Okay, so find the initial height of the cannonball. Oh, that would be the height at time 0. At time 0, that's the y-axis, that's the y-intercept, and this is 12 feet. How do I know that? Because the constant is 12 feet. Now, you can also put this into your graphing calculator. You can't use t's, you have to use x's. But you will see that at time 0, when you initially start, that it's 12 feet. Okay, algebraically determine how long it takes for the cannonball to reach maximum height. All right, maximum height, that's the point up here. That's the vertex. You can find the vertex by doing x is equal to negative b over 2a. That's a piece of the quadratic formula, all right? So x is equal to negative 200 over 2 times negative 16. So x is equal to 6.25, and this is in seconds. 6.25 seconds. So it's pretty fast, 6.25 seconds. Okay, algebraically determine the maximum height. Well, the maximum height occurs at 6.25 seconds. So I can just plug that 6.25 seconds into my calculator. So I got this, it's right here, negative 16, 6.25 squared plus 200 times 6.25 plus 12. And that's algebra, guys. When you substitute things into an equation, that's using algebra. So when it says algebraically, it's basically saying, don't guess, don't do a graph. But that doesn't mean that, let me calculate while I talk. That doesn't mean that you can't do a graph to check it. Okay? Oh, pretty cool. 637 feet. Okay. That is a pretty powerful cannon. Okay. To the nearest tenth, major hint that there's going to be some rounding involved. How long will it take for the ball to reach the ground? Okay, so it goes up, it comes down. When will it hit the ground? The ground is always 0. Ground 0, that's a real thing. Okay, so when will this hit the ground? Negative 16t squared plus 200t plus 12. All right. So again, I would totally quadratic formula this thing. The reason I would quadratic formula this thing is I'm quite certain, because it says to the nearest, I keep pointing at it and you can't see that I'm pointing at it, to the nearest 10th. That's like a major hint that this is not going to be an integer value. All right. So now if I put this into my quadratic formula, I'm going to go down here. Okay. All right. So that's x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay. All right, so I'm going to pop that into my calculator. And you're going to have to actually calculate it twice. I'll show you one of them, and then I'll show you how you can do the other one. But I'm not going to enter them both because I don't want to spend a lot of your time. You can just pause me and do it on your own, okay? So again, alpha y equals will give you the fraction, okay? So if you want to do that, you can use the fraction. You can get alpha y equals. All right, so first I'm going to do my discriminant. The discriminant is what is underneath the radical sign. And the discriminant, remember, that always gives me the nature of the roots. So I'm totally hoping this is not a negative number, because if this is a negative number, then Mrs. Laurentini wrote a really bad question, because we're looking for an answer here. All right, so I end up with 40,768. I do not know the square root of that number. Do any of you? I don't think so. I don't think any of us know that one. I don't think that was on my chart. Okay, so negative 200 plus. You can't enter a plus and a minus at the same time. So you got to do the plus, and then you got to go back and do the minus. Okay? The square root of, so second squared gives me square root. And you can see when I push the buttons, they turn red. So hopefully that's helping you figure out what buttons to push. But by now, this calculator should be your friend. And unfortunately, you don't get to take me to geometry with you. I would go, but you get to take your calculator with you. Okay. All right, so look, hey, negative answer. That's not good. So that would be rejected because it doesn't fit our domain. All right. So now this is what I do, is I use this up arrow and I get this to be blue. I'm not sure if it's blue on everybody's calculator, but you get it highlighted and you hit enter. And now the only thing that I have to do is change that plus to a subtract. So it saves me a little bit of time. Oh, 12.559, blah, blah, blah. Irrational, doesn't matter because I'm supposed to round. So that's over here. So that's going to give me 12.6. Okay, so I'm right here. How long will it take for the ball to reach the ground? 12.6 seconds. Okay. What is the interval of time when the ball is at least 500 feet? So it's a similar question to the one we just did, except for instead of it reaching the ground, which is a height of 0, it's going to reach a height of 500. So I'm going to start like this. 500 equals negative 16t squared plus 200t plus 12. Set it equal to 0. 0 equals negative 16t squared plus 200t minus 488. So again, very similar to this, except for you'll see that the c is a different number. Okay, so I have to amuse myself. I hope at least one of you is laughing, okay? X is equal to negative b plus or minus square root. I'm not going to draw my face. Okay, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so x is equal to negative 200 plus or minus the square root of the magic of having my work done so I don't take up too much of your time. All right, so if you calculate your discriminant, you get 8,768. Okay, so it says from blank to blank, and I really should have put nearest 10th here, so I apologize for my typos, but that's nearest 10th. Okay, so I would get, from my calculator, I got 3.3 yada, 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 which is 3.3, and I got 9.17 yada, 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 and you can do it on your calculator as well. You should be doing it on your calculator as well. You're supposed to be doing the work and checking the work, not just copying the work. So it's up in the air at least 500 feet. So just picture the parabola. Here's my really bad picture, and here's 500 feet. It's from here to here that it's 500 feet. Okay, so how long is it there? Well, it's there from 9.2 to 3.3. If I do a little bit of subtraction, 2 take away 3 is 9. So 5.9 seconds. Okie dokie. I hope that makes sense. And I can always explain it again, or, you can always phone a friend. Hey, did you get what Mrs. Laurendini said? I didn't get it. Maybe you can help me. Be social. Okay. So, all right. Initial velocity. Here's the thing. The initial velocity is always the coefficient of the linear term, and no, you don't have to know that. So when I write my function, I'm just going to use a k just because I feel like it, okay? So k equals, it's always negative 16 because that's gravitational pull. And then the initial velocity is always the coefficient of the linear term, and the cliff is 480 feet high, so he's at 480 feet. Okay, not very realistic question, but it was fun to write, okay? So here's Mr. Katz. Do not tell him I drew him to look like this. And he's on a cliff. And he jumps up and goes down into the water. Parabolic. All right. So what was the highest point that Mr. Katz reached? Well, that would be the vertex. So that's somewhere around here. Right, the vertex. And when did he hit the water? That's down here, and there's the splash, splash. Okay. All right, so what's the highest point? So we got to do x is equal to negative b over 2a. So x is equal to negative b over 2a. X is equal to the negative of 16 over 2 times negative 16. So that's negative 16 divided by negative 32, which is 0.5 seconds, which doesn't answer the question because it says what is the highest point. So it's the height at which 5 seconds occurs. The height at which 5 seconds occurs. So that's substitution. So I'm going to plug in that 0.5. So when they ask you questions about vertex, you always have to make sure you refer to the x and the y. This is just really asking about the y. The x is usually the time. Time is very common to be your x variable in questions like this. Height is very common to be your y variable in questions like this. And what is the highest point he reaches? I'm sure by now you don't have to see me enter the calculator, but if you do, give me a call. Okay? Oh, 484 feet. Oh, this is not a very nice question. That means he jumped, 4 feet. I can't jump 4 feet. That's a lot. He jumped high, 4 feet above there. Yeah. Okay. So this right here, 484 feet. When did he hit the water? The water is 0. So again, we set it equal to 0 and we solve. And now you'll see why I chose 480. All this can be divided by negative 16, which makes it much easier to work with. So 0 equals x squared minus x minus 30. Coolio. X minus 6, x plus 5 equals 0. So x equals 6 and x equals -5. Reject the negative because time cannot be negative. So he hits the water at 6 seconds. Okay? I hope you can read my really bad handwriting today. All right, so now this right here, homework, work that we do at home. All right, so Mr. Bello is launching a rocket. The path of the rocket can be modeled by this equation. Okay, now I'm saying that the height is in feet and the time is in seconds. The height is in feet and the time is in seconds. Please do your absolute best to work on this question by yourself. And if you need any help, just reach out. Have a great day.